Hello students, welcome to my YouTube channel. We are going to continue with the next payload questions in this video lecture. So far we have done 35 questions. In this video lecture we will do the next 5 questions. So let's start with question 36. What is the maximum allowable traffic load for the following aircraft whose dry operating mass is given? Performance limited and maximum structural limited takeoff mass are given. Performance limited and structurally limited landing mass are given. Zero fuel mass, total fuel, trip fuel, startup and taxi fuel are given as well. So let's start with our step number 1, which is draw three columns, one for takeoff mass, the second one for landing mass, and the third one for zero fuel mass. In the takeoff mass column, you are going to write a value which is lower of performance limited takeoff mass and maximum structural takeoff mass. In the landing mass column, you are going to write a value which is lower of performance limited landing mass and maximum structural limited landing mass. To that value, you are going to add trip fuel. Trip fuel. In the zero fuel mass column, you are going to write down maximum zero fuel mass plus fuel on board or takeoff fuel. Okay, so you have to go into substitute values in that formula. Now let's start with column number 1, which is a value to be chosen which is lower of performance limited takeoff mass and structural limited takeoff mass. Performance limited takeoff mass 64,000, structural limited 66,000. So 64,000 is less than 66, so I'm writing 64 here. In case of landing mass column, performance landing mass is 53,000, structural landing mass is 54,000. So 53,000 is less than 54,000, so write down 53 plus trip fuel. Trip fuel is 12,000, so write down 12. 53 plus 12 is 65. Now zero fuel mass. Now zero fuel mass is 52,000, so write 52 plus fuel on board, which is total fuel. So fuel on board is nothing but your takeoff fuel, and takeoff fuel is nothing but fuel available in the fuel tanks when your aircraft has lined up with the runway. It's ready for takeoff, run, and takeoff. Okay, so fuel in the fuel tanks at the start of takeoff run is your takeoff fuel. To get takeoff fuel, you will have to subtract startup and taxi fuel from the total fuel on board. So fuel on board is 16,000 minus startup taxi fuel is 500. Therefore, takeoff fuel will be 15,500 kg or 15.5. So 52 plus 15.5 will be equal to 67.5. Now out of these three values, 64, 65 and 67.5, 64 is the lowest value, and that value, and therefore this value will be our regulated takeoff mass. What does the rule say? The rule states that we have to choose a takeoff value which is the lowest of all the three takeoff values. Therefore 64 becomes our regulated takeoff mass. Now let's proceed to step number 2, which is regulated takeoff mass equals to dry operating mass plus payload or traffic load plus fuel on board or takeoff fuel. Substituting the values, you get 64 equals to dry operating mass is 37,000 or 37. Payload you don't know, so write it as it is. Fuel on board is 15.5. So 15.5. Instead of writing 15,500 or 64,000, 37,000, I have divided those big numbers by 1,000 to get a smaller number, 64, 37. It becomes easy for calculation. Therefore, payload will be equal to 64 minus 37 plus 15.5. 64 minus 52.5 is 11.5 kg or 11,500 kilogram. So the correct option here will be option Bravo, 11,500 kilogram. Okay. So 36 answer is A. Correction, Bravo, 11,500 kilograms. Let's go to question 37, which is a similar question to be in which we have to find traffic load, structural landing mass given, performance landing mass given, zero fuel mass given, DOM, total fuel, startup fuel, trip fuel are given. Now in this question, we have not been given structural limited takeoff mass and performance limited takeoff mass. So we will have to draw only two columns, one for landing, another for zero fuel mass. Step 1, takeoff correction landing mass column and zero fuel mass column. In the landing mass column, you are going to write a value which is lower of performance limited landing mass and maximum structural landing mass plus trip fuel. In the zero fuel mass column, you are going to write the formula zero fuel mass plus fuel on board or takeoff fuel. So between maximum landing mass and performance limited landing mass, 53,000 kg of performance limited landing mass is lower in value. So you are going to proceed with that. 53 plus trip fuel is 17.5. 53 plus 17.5 is 70.5. In the maximum zero fuel mass column, 51.4 plus fuel on board, not given to you directly, but we can subtract total fuel minus startup and taxi fuel. That will give us fuel on board or takeoff fuel. So total fuel is 20,000 minus 0.35 is 19.65 kg. So 51.4 plus 19.65 is 71.05. Now between 70 decimal 5 and 71 decimal 05, 70.5 is the lower value and this becomes our regulated takeoff mass. So regulated takeoff mass equals to dry operating mass plus payload plus fuel on board or takeoff fuel. Substitute the value 70.5 equals to 34.5 plus payload or traffic load plus fuel on board, which is 19.65. Therefore, payload will be equal to 70.5 minus 34.5 plus 19.65. So 70.5 minus 34.15. So that will be equal to 16.35 kgs. 16,350 kg. So the correct option here will be option Bravo, 16,350 kg. Okay, 37 is Bravo. Let's go to question 38. Which of the following statements is true? Variable load is equal to basic empty mass minus zero fuel mass. Traffic load is zero fuel mass minus dry operating mass, which is correct. Variable load is dry operating mass minus zero fuel mass. Operating mass is zero fuel mass plus total fuel. So delta is correct. A and Charlie are wrong, Bravo and Delta are correct. Okay, so I'll draw the flow chart again. You start with basic empty mass, the most basic weight of your aircraft, standard equipment, unusable fuel, oils, etc. etc. When you add variable loads to that, you get dry operating mass. You get dry operating mass. When you add when you add takeoff fuel to dry operating mass, you get operating mass. So upon adding takeoff fuel or fuel on board, that is fuel in the tanks at the start of takeoff run, you get operating mass. After adding payload to dry operating mass, you get zero fuel mass. Next, after adding payload, now takeoff fuel we have added, now what's remaining? Payload or traffic load. So after adding traffic load or payload to operating mass, and in case of zero fuel mass, you have payload, you do not have fuel. So now is the time to add fuel. You get, in both cases, you get the same quantity, that is takeoff mass. So you may get takeoff mass by following this course or this route. Okay. Other important points: takeoff fuel plus payload is equal to, is nothing but your useful load. Useful load. Okay. Takeoff fuel plus payload is useful load. And dry operating mass plus useful load will give you takeoff mass. So this is the third way you can get takeoff mass. Dry operating mass plus useful load, a combination of fuel and payload, will give you takeoff mass. So in this question, its first statement option says variable load is basic empty mass minus zero fuel mass. So see, variable load is here, basic empty mass is here, and zero fuel mass is here. So there is no direct relation between basic empty mass and zero fuel mass. Okay, so by subtracting basic empty mass from zero fuel mass, you won't be getting variable load. To get variable load, you have to subtract basic empty mass from DOM. Okay, and the next traffic load is zero fuel mass minus DOM, which is correct. Okay, and zero fuel mass plus fuel is your takeoff mass actually. But in Keith and Williams, uh, they have given that operating mass equals to zero fuel mass plus fuel. According to me, the correct answer should be uh, DOM plus takeoff fuel should be your operating mass. Okay, DOM plus takeoff fuel should be your operating mass and not zero fuel mass plus fuel. Anyways, but that's what given in the book. So option Bravo is definitely correct. Option Delta can be rectified and made DOM plus fuel instead of zero fuel mass plus fuel. Alpha and Charlie are outrightly incorrect. Question 39. What is the maximum allowable traffic load for the following aircraft? First, DOM is given to you. Performance limited takeoff mass, landing mass, structural takeoff mass, structural landing mass, zero fuel mass, fuel, startup, and trip fuel are given to you. So let's draw three columns, one for takeoff mass, the second one for landing mass, and the third one for zero fuel mass. In the takeoff mass column, you are going to choose a value which is the lower of performance limited takeoff mass and maximum structural takeoff mass. In the landing mass column, a value which is lower of maximum structural landing mass and performance limited landing mass. To that, you are going to add trip fuel. In zero fuel mass column, you are going to write the formula zero fuel mass plus fuel on board or takeoff fuel. So lower between performance limited takeoff mass and maximum structural takeoff mass, 67,400 is more than 66,000, right? So we are going to go with 66,000 kg, or we are going to take off with a mass of 66,000 kg. So I'm going to write 66,000 here. In the landing mass column, any value lower of structural landing mass or performance landing mass. Now, structural landing mass is 54,000, performance landing mass is 52,800. Between them, performance landing mass value or performance landing mass limitation is lower than the maximum structural landing mass. So select 52,800, add trip fuel to that. Trip fuel is 12,400, so plus 12,400 next. So that will be equal to 65,200. Now zero fuel mass given is 52,000. Fuel on board or takeoff fuel is not given to you directly. We can calculate that fuel on board or takeoff fuel is equal to total fuel in your tanks minus fuel consumed in startup and taxi. So 16,000 minus 12, correction, minus 500 is 15,500 kilogram. So 52,000 plus 15,500 amounts to 67,500. Now out of these three values, 66,000, 65,200 and 67,500, 65,200 is the lowest value. So this value becomes our regulated takeoff mass. Now let's proceed to step number 2, where we are going to use formula regulated takeoff mass equals to DOM plus payload plus fuel on board or takeoff fuel. Regulated takeoff mass is 65,200. Dry operating mass is 37,500. Payload we do not know. Fuel on board is 15,500. Therefore, payload or traffic load will be equal to 65,200 minus 37,500 plus 15,500. 65,200 minus 53,000. So 3 is 2. So 12,200 should be the answer. Bravo is the correct answer. Okay. Question 40. What is the maximum traffic load for the following aircraft whose DOM, takeoff fuel is given, and takeoff mass, landing mass are given? So there is no need to make all the three columns. We can just directly choose one takeoff value. Now what is the formula? Formula is regulated takeoff mass equals to dry operating mass plus fuel on board plus payload. So over here, takeoff mass and landing mass are given to you. Now to use landing mass, we will also have to know trip fuel. When we add trip fuel and landing mass, we get a takeoff mass. Now over here, trip fuel is not given to you. So the information about landing mass of aircraft is not useful. So we will consider this takeoff mass and proceed with the calculation. 3650 equals to 2100 plus 350 plus payload. Payload will be equal to 3650 minus 2400 2450. That is equal to 1200. So the correct answer is option A, 1200 kilogram. So this is how you do this sum. With this question, we stop here. I'll do the next questions in the next video lecture. So I urge you all to keep practicing all the questions that I have done so far. If you have any questions or doubts, let me know in the comment box. And I request you all to subscribe to this channel and share this video with all your friends. See you in the next video lecture.